Okay, so hello. Has a small disclaimer. Yesterday I kind of changed a lot of the third side of the presentation. I was trying to make it fit on the screen when I noticed that the room was very long. So if by any chance one or two of the slides are not readable on the end, I apologize. I try to do my best to expand it as much as I can. And I'm here to talk about JavaScript craftsmanship, clean code. My name is Francisco, as I got introduced. I'm a software engineer at the European Product Development Group that is spread across London and Zurich. The main product side is here in London, London and Berlin. The main product side is here in London. Has everything, sorry, the small disclaimer. This presentation is my opinion. Don't take it as a statement from eBay or anything like that. So I'd like to talk to you guys about clean code, how readable code is, how to make your lives easier, how to lower frustration on the long run. And the first thing that I wanted to address is that code readability. If I get you a show of hands, how many people got already their managers are asking them, can you please do this small task? And you replied, yeah, that's fine, I can do that in 5 to 10 minutes, maybe an hour, and it's done. It's something really, really quickly. Yeah, cool. Okay, and how many of you, after saying, putting the expectation that you're going to be able to do that in 1 hour, which is fantastic, started looking at the code base and found something like this? So the reality is that this plagues many, many projects. Especially if you're working with teams that change constantly, if you're working with environments that force you to deliver very quickly and not really take care of what you're doing. The reality is that people start pushing functionality out very quickly, but very soon it becomes a mess. And this task that you said that it took you 1 hour to do actually ends up on consuming lots of time to find the place that you want to change it. And when you probably find the place that you have to make the edit probably is going to take that 1 hour that you said in the beginning. But the reality is that you have absolutely no idea if you're going to change, if you're going to break stuff, or, well, in this case, it has everything mixed together. You have guys riding bikes while others play football, so the code is kind of the same. This kind of code, let's not use a find Wally image for that. This kind of code, it's something that for me looks like this. This example, sorry, the arrow, but it didn't fit in a single slide, is actually from one of the main newspaper sites in Portugal. It's called sol.pt, and I was inspecting them quite happily because the site was going really, really slow, and I found this. So this is the page that this is the code that loads the homepage. It's the code that loads their main money driver. And it looks like someone simply came here and copied a bunch of code from Stack Overflow, pasted everything together, and they made a website for a newspaper that somehow has a huge turnover and is making profit. And not to make things worse, they even nest 4 layers of Ajax call to load the initial page. And the reality is that if at any time you want to do any kind of changes on this, it's going to be a copy-paste nightmare, and you're probably going to break everything. And honestly, I would not feel confident at all in touching something like this. I'm not going to explore the selectors and everything. It's just bad. So in the end, what does define good code? Now, this is my perspective. If you disagree, please follow in the next half an hour to discuss upstairs. But in my perspective, what defines good code starts with a very, very simple set of things. I would say that it starts by having tests. I like this image because it represents the tests in code very well, actually. Tests should be running independently. They should not be copying material from one and another. They should be well-structured, running in parallel, and simply guaranteeing that what you thought that you know, and also what you forgot that you knew about the project still works. And if you want to have really good code, testing is one of the most fundamental parts of what you're doing. If you don't believe in it, that's perfectly fine. Please print this guy, put it above your laptop, and let it count every day until you decide to start doing tests. because it really is going to make your life different. The other thing in terms of writing clean code, I would say that it's one of the two hardest things that we have, which is giving proper names to things. I'm not going to talk here about invalidating caches or off-by-one errors, but I will try to explore a little bit during this talk, naming of stuff. Simply because if you write production code that looks like this, there is a special place in hell for people that do this. Honestly, I would not feel confident in changing this. Most likely, if someone said there is a bug here, I would simply delete all the code that's here and refactor this. Has a disclosure to the guy that did this. This is a copy-paste from one of the first solutions in Google Code Jam, so those guys, for programming context, you can understand it. So let's explore the first part. Let's explore a little bit about tests. What I want to talk here, it's given that tests is one of the most important things for you to understand code, tests are your contract. For example, if, especially in JavaScript, where you have this beautiful describe structure that is very behavioral, you really don't need comments, because if you're commenting your code, you probably could remove the text that you have on those comments, put it on the testing, has the describe text in JavaScript, on the describe itself, and you end up with having a code without any comments, and you have your comments on the describes and on the it. It makes things really easy to do, and you also establish a contract. The thing about tests is that many people do tests like this. If I would ask someone to, does anybody could feel confident that they could explain me what's on the screen? Yeah, exactly. So if you would, you would be really, really good navigating through mazes. That code has had its assertions, but if we visit it, it has like 2/3 of it is building boilerplate, and then you have assertions in the end that have absolutely no correlation with what the test is stating that it should do on the it. So yes, you would be going through a maze if you ever have to. If this test ever breaks, it's going to take ages for you to understand what's wrong. So I would like to give a quick example. This is from some code that we have that we have running in an app at eBay. Don't expect big stuff. It's very small, especially so that it can be used as an example. It's pretty much a test for the code that allows us to detect which environment we're in. Our platform pretty much gives us a bit of environment, and we have multiple staging and QA pools, and this pretty much allows us to know where we are. If we look at these tests, you can use, we've been given in JavaScript and like Java a really powerful way to structure our tests. We have describes that state the assumption of the environment that your test is running. And you have the it, which describes the intent of the test itself. So if you look at, in this case, when in dev, the before it simply guarantees that the expected environment is always set properly before. And you go read the test, it should detect dev. The naming inside makes it really, really easy to read. Environment is development should be true. So the part that I wanted to look here is not at the piece of code itself. It's that the it clauses, the place where you're running your tests, only have one single assert. Well, they can have more than one assert, but they have absolutely no logic code running inside the it. I'm going to show you another quick example. This comes from a caching system that we're using in some of our projects. It's released on NPM if anybody wants to use it. It's nothing more than a cache with a timeout. And the intents are all there as well. You have the environment on the describe after adding an element that before each guarantees that that element is put before every single test run that exists. And it should be retrievable. Again, give good name to things so that people can go into it and simply read it. Cache, get key should equal value. And if you want these describe structures, it's especially cool because you can nest steps. So in here, we have a describe after adding an element with another describe remove the element, which is the natural step that you use on a cache. You first add the element and then you remove it. Both before eaches, the put and the remove get executed one after the other. And in the end, you can verify again a simple assert with it should disappear from cache. I don't know if anybody notices the inconsistency on what I'm saying. Actually, in the middle of the code, I'm running logic inside the it. That is because I got really lazy when I wrote this piece of code and I didn't refactor it. But ideally, that cache clear should not be there. It should have another describe. And instead of saying it should be able to clear the cache, we should say describe after adding an element, then put another describe when clearing the cache. It should be empty. And the clear can go into the before each of that describe. And this way, you can simply, if you want to test more stuff for that set of ecosystem that you generated, you're guaranteed that it's running every time you run tests, so you just need to add it clauses with assertions for what you actually want to test. Also, one of the things that this testing like this requires to have good structure, ideally object-oriented code, and we'll get into that in a second. But having all these describes, it's also cool because probably you guys have heard about Mocha. I'm not going to try to evangelize anybody for any testing framework. I just like Mocha because it outputs things really nicely. But if you put this describe structure, it becomes really easy to see what's going on the terminal. You run the tests, and this can be running on a continuous integration service. And you can go there and you see, in this case, if environment, when in QA, should detect QA. Even your PM, if you're working on an agile infrastructure and the build fails, even your PM can click on the link that goes into the console and see exactly what is currently failing so that he can warn the stakeholders that things are probably going to be delayed. So giving good names both to test and to code pretty much leaves you with enlightenment. You're sure that if you're going to touch code, things are going to be working afterwards. And you're sure that if you visit your code after a couple of months, even a year, that there is still a contract in place that guarantees that the assumptions that you were doing when you wrote it, that they are still true. So let's go a little bit into how structuring code so that it's easier to write these tests can help, and also talk a little bit about object-oriented. We only have around 20 minutes, so I'm not going to go very much in depth into object-oriented. Just want to give some quick examples. First of all, I don't believe that JavaScript can be completely object-oriented. It can simulate object-oriented, and we can use it as object-oriented like code programming. But if I would ask here, how many of you guys can, with certainty, say, I know object-oriented programming? Cool. So for those that raise their hands, although this doesn't apply to all the languages, I would expect that you would be able to at least describe what each of these keywords mean. Probably people that come from from more object-oriented programming languages such as Java or C++ can state them all. But there are some of these that are not simulatable in JavaScript. So in the end, JavaScript is prototypal, it's not object-oriented. We can simulate a couple of them. We can simulate static, we can simulate publics and privates. We can even extend, but for example, you cannot have protected variables or interfaces very well. So it's not an object-oriented language in itself. But we can use it, and we can actually write code that people that come from a Java environment or from any other more strict language can go into your code and actually understand what things are going on. So I think this is the slide that the guys over on the end cannot see it very well, so I apologize. It's just this one. This is just a quick example of how you can achieve object-oriented like structure in JavaScript. There are others. There are countless different ways as you can define objects in JavaScript. This is my favorite, so I'm going to use this as an example. Pretty much what we have here is, again, the code for that caching mechanism that I showed you on the test. You have code that you put inside the scope. That code becomes your private properties. So every time you build a new instance, all of these are going to be regenerated, and it's in scope to that instance, and it's private. While these ones here on the bottom, you can attach them directly to the this. The this must exist, which means that this object can now only be used if you do use the new keyword with it. You attach things to the this, and they become instant public. There are some side effects on this. Has the thing that we have on the top of having the that equals this so that you can access the scope from within the other functions. But with this, you pretty much can go into a very much object-oriented like programming and have everything contained in a single class. Personally, I don't like much prototype chaining more because in the end, you end up with having many things defined across a file, and they are not actually contained within a single class. And you cannot really have private functions, and that for me is a problem. Especially if you want to share code with other people, you need to give them the contract of what they can actually use. So being able to separate private and public really does make a difference. Again, this helps because you can focus on the naming of things. And one of the things that you need to focus is that the name of the object, if you use a structure that you intend to be used as an object, you should capitalize the name. You should put a capital name so that people who are going to use that object know that it's something that they must instantiate. Because if someone tries to run this without instantiating an object first, they simply are going to attach a bunch of things to either to the window or to the global scope, and that doesn't really work very well. So if we look then at this, the fact that you capitalize the name, and you can then use the new keyword. The new keyword is very semantically explicit, which means anybody going through your code will know that they are generating a new instance. And it's something that comes from many other languages as well. So it's easy to understand what its intent. And it forces people to write less cryptic code because they are forced to write instantiable objects, which in turn needs to have some structure on it. So having the new pretty much means I need a new one. Looking at the environment, just to give you another quick example. Again, I apologize to the guys in the end if this is a bit hard to read. It's exactly the same. In this case, it's a very small piece of code. It just verifies a string that we have in the app context that says that if you're in production or in QA. And in the end, you can start using design patterns that are accommodated to object-oriented programming. In this small case, we have a singleton. In the end, we have module exports with saving the instance in itself, so it becomes an enabler of other practices that people are already used to using. So now, this is the part that's going to be risky for me to speak. Let's talk a little bit about functional in the sense of how functional can help building readable code. I have to admit from the entire presentation, this is the one that I'm most afraid of, so let's see if I can do this properly. So, talking about functional code, I don't know, I started working with functional code with Lisp around 10 to 15 years ago. I love Lisp, and when I noticed that JavaScript was something that we could use functional in, I could not stop. And so, but many people have no idea how actually that functional is a different paradigm from all the other procediments, so from object-oriented or procedural coding. So let me give you a quick example of how it works. By the way, forget that I have an error there. Adding 3 plus 4 is not 4. But if we have a function add, and the function simply adds returns a plus b, and I want to build a new function, a function that is called double, and that function, what it does is you pass a value into it, and it returns the double of that value. It would be really cool so that I don't just write a bit of code that says return 2 times whatever value is passed, that I could reuse the function that already exists. So I want to reuse the add function, and I want to say add twice, it's going to be our double. A way that we can do this is, and this is normally what mind blows people when they start touching functional programming in JavaScript, is that the function that does this, which is very useful, it looks like this. The concept here is that by chaining functions and passing functions around, you can make things really, really readable. In this case, the twice, what it is doing, it's that it's going to do twice of whatever you pass into. So in this case, we are passing the add, And the twice simply returns a new function that accepts just one value instead of two values. And it's going to run whatever function we passed in with the same value on both sides. So you can do twice the addition, you can do twice the subtraction, that would be 0. You can do twice a multiplication, whatever. And for example, if you do twice multiplication, you would get a power of 2. So it's nice. It's really fun to use. Once you start using it, it's awesome. And it also helps making things readable. Let me give you some examples. So right now it's... let's look at this function. So this is a bit of code that we have at eBay. This was before I did a refactor on it. And I would like you guys to notice for now this success function here. It has an ID, and that ID comes from the scope of this function, and we are simply on success passing a callback into it, pretty much standard stuff that everybody does on JavaScript every day. And also we have these two calls on the bottom that are kind of repeated. So let's see how we can play around with this. Let's start with looking at this one. So again, it has an ID, and I want to remove the function that I'm passing anonymously here. One way that you can do this is by creating a new function. And in this case, if you look on the bottom before looking to the top, it becomes really easy to read. You have the update type term preview, you do a get on something, and when it renders on success, run the iframe loaded callback. The thing here is that we removed we abstracted the whole function that was there, and we gave it a name. So someone who goes reading into that code no longer has, and sometimes you have multiple places with anonymous calls, one on top of the other one. This helps things become much more readable. You simply start building functions that return a single function, and you provide that function anywhere that you have a callback to pass. Now, looking at these two pieces that we had on the bottom, this can actually also be abstracted. But we could use a message bus to solve this. But just for fun purposes, yeah, I need to wrap out, so I'm going to accelerate. We could also put them on a list and simply generate a call function call. And then if they share the same functionality, because they probably extend something, you can just put them on a list, map it, and call the function itself. So the code in the end looks like this. Here is another example. If you look at the promises that are exactly in the middle of the code, they again simply are running functions that return a function, and it becomes really easy to read. So you go get the promise, when it finishes, then remove from pool, then execute next promise. So it helps with the readability a lot. Sorry for accelerating this last part, but any questions, please join me in the next half an hour. I hope you enjoyed it. And again, I apologize for the third part of the presentation. I kind of mangled it yesterday and had to improvise a bit. Thank you.